Hello everyone, welcome back to another episode. Today we're going to be doing the running diver problem, which is described as such. How fast must the 510 Newton diver run? Well, for this problem, I'm actually going to give you a hint. They are tricking you. This 510 Newtons, the weight of the diver, we do not even need that. This 510 is a bunch of baloney, so we can just... Don't believe me? Let me prove it to you. Okay, so here is the picture that's provided. We've got the diver who's up on a ledge, and it's 9 meters tall, and he's trying to clear this horizontal ledge of 1.75 meters. And he's got to run at a speed, Vx naught, to just clear this corner and land safely in the water. Although in real life this diver is quite big, we can treat this diver as a particle. You don't really need to think too deeply on that, but we're going to be setting the x final to be 1.75 meters, and in reality, if that's all that he or she cleared, he would probably nick the ledge with his knees or something. But for this case, let's think of him as a particle. Okay, so let's get started. Let's write down what we know. X naught, we can call 0. X final, we're calling 1.75 meters because that is this point. We want him to just clear that. And we can call the origin right here 0 in the x. Okay, so the initial velocity that he's running, we don't know. The final velocity is going to be equal to the initial velocity in the x direction because the acceleration in the x direction is 0 meters per second. Time it takes to get there, we don't know. Now let's write down what we know for the y's. We know that the initial height is 9 meters. We can say that the final height here, if we're calling this 9, then we have to call this 0. So the final is 0 meters. The initial velocity in the y is 0. This person is running perfectly horizontal, and he's not going to be jumping upwards. And the final velocity in the y direction, we don't know. Acceleration due to gravity is always negative 9.81 meters per second squared. Time it takes to get there, we don't know. All right, so for this one, it's going to be helpful to jump right into the y equations. For kinematics, the short and the long equations and the y. And you're going to see just why that is in a second, because with the y, given the height, we're going to be able to find how long it takes for the diver to reach the point of the water. And then with that time, we can go back over here to the x and solve for how fast he or she must run. So let's get into it. I'm going to do the y equations in blue off to the right over here. So I've got the long equation, y minus y naught is equal to vy naught t plus 1/2 ay t squared. Now we know that the final y is 0. We know the initial y is 9. We know the initial velocity in the y direction is 0. So that's going to zero out that term. And acceleration due to gravity is negative 9.81 meters per second squared. Okay, so what we're left with is negative 9. Oh, shoot, said I was going to do it in blue. Negative 9 is equal to negative 4.905 t squared. And then what we're going to do is we're going to take this negative 4.905 and divide it over here, so we're just left with t squared. And then we're going to take the square root of both sides and solve for t. So solving for t, we get t is equal to 1.35 seconds. Boom. And then with this, we can take this and put it right in there. So now we know that t is actually 1.35. And it turns out that the long equation was all that we needed for the y's. We're going to now move on to the x equations. And because of this time, we now know this time, we are going to be able to find this. Because look, this is the only thing that we don't know. So let's move on to the x equations, okay? So I'll do the x's in black. So we've got x minus x naught is equal to vx naught t plus 1/2 ax t squared. We know that the final x is 1.75 meters. We know the initial is 0. The velocity initial we're going to be solving for, but we know t is 1.35 seconds, and we know that acceleration in the x is 0. We're basically, what we're saying there is we're saying we're ignoring air resistance, and that's what we need to do in order to solve this problem. Okay, so what we're left with is 1.75 is equal to Vx naught times 1.35. And then we're going to do the similar thing where we're going to take this, divide it over here to isolate the initial velocity in the x direction. And by dividing 1.35 over, we're going to get Vx naught, which is the speed that he or she must run at, is equal to 1.30 meters per second. And there it is. That's how fast this diver must run in order to clear this ledge and make it safely into the water. Told you, this 510 Newton thing that they were giving us, the weight of the diver, we didn't even need it. So they were trying to fool you. Don't let them fool you. Use the short and long equation. And if this video was helpful to you or you enjoyed it, give it a thumbs up, subscribe to the channel. Thanks for watching.